Alright, so this is our quiz review 8.1 to 8.5. Let's start off with number 1. It says to find an explicit and a recursive formula for the following sequence: 2, 5, 8, 11. The first thing I'll say is you want to make sure that you always have your formula sheet right there in front of you. So here's my formula sheet. You have one there that's in OneNote. There's a page that says formula sheet. And so this is just a nice place where all your formulas are there together. If you want to go ahead and write recursive formulas on your formula sheet, so you could add to your formula sheet recursive formula for arithmetic sequences, and then you could also add recursive formula for geometric. They're almost the exact same. So these are the formulas that have two parts. A sub 1 is the first term, and then a sub n is the previous term plus the constant difference. For geometric, we tend to use a different letter, G for geometric, but we still have the first term. And then the nth term is the previous term times r, because we're multiplying for geometric, whereas we're adding for arithmetic. So arithmetic has a constant difference, geometric has a constant ratio. So you might want to add that to your formula sheet so that when you're solving these problems, you have one place that you can look. This is, I don't know what happened here. It's supposed to be the word geometric. It doesn't look like it though. There we go. Okay. All right, so that's our formula sheet, and I'm going to be looking at my formula sheet as I go through all of these problems. So the first problem says find an explicit and a recursive formula for the following sequence. So I first need to figure out what kind of sequence this is. I notice right away that it's increasing by 3. I think that's obvious. If you're not sure about that, what you always do to check and see if it's arithmetic, excuse me, or geometric, is first see if there's a constant difference. 5 minus 2 is 3. 8 minus 5 is 3. 11 minus 8 is 3. You always do term minus previous term. It has a constant difference. And so I know that I'm always adding 3 to the previous term. And I usually like to write that down. And I look at my, I want to write my explicit formula. That's going to be a sub n. If I need to look at my formula sheet, I can. It always starts with the first term, which is 2. And then I add 3 times n minus 1. Another way to write this explicitly would be to distribute the 3 and simplify. So another way that we could write the explicit formula would be 2 plus 3n minus 3. I distributed that 3, and then when I combine the 2 and the negative 3, I actually just get negative 1. So I could write it either way, one or the other. It's not these two together, it's just this one or this one. All right, recursively, I'm going to have a sub 1 is the first term, which is 2. A sub n is the previous term plus 3. And I go to number 2. This looks like it goes up by 8, and this goes up by 40. So I realize this is not arithmetic. So then I check to see if there's a constant ratio. What's 10 divided by 2? 5. What's 50 divided by 10? 5. What's 250 divided by 50? 5. So I know that this is geometric. I'm multiplying by 5. So my explicit is going to be g sub n equals the first term, 2, times the constant ratio, which is 5 to the n minus 1. Remember, if we start with the first term, this should be to the n minus 1. Recursively, my first term is 2, and g sub n is the previous term times 5. All right, this year you guys get to skip 3 and 4. Let's go on to number 5. Number 5, when I see this, this is a summation or series problem. That's what a series is. It's a summation. So I know that I'm going to be using one of my sum formulas. So I look at my formula sheet. Am I going to use a sum formula for a finite arithmetic or a sum formula for a finite geometric? Well, anytime it looks linear like this, that's going to be arithmetic. When we get down here to a problem like this, I can tell this is exponential. That's going to be geometric. All right, so let's look at this. I'm going to use my formula, S sub n equals, I'm just getting this right off of my formula sheet, n divided by 2 times the first term plus the nth term. This is the formula that I'm going to use. So I'm going to be adding up the first 5 terms. So S sub 5 equals 5 divided by 2. Notice these should always match. The first term I would find by putting a 1 in here. 2 times 1 is 2, plus 3 is 5. So 5 is the first term. To find the nth term, which would be the 5th term, I'd put a 5 in here. 2 times 5 is 10, plus 3 is 13. So I'm going to go ahead and I'm going to put 2.5 times 18 into my calculator. 2.5 is the 5 divided by 2. 5 plus 13 is where I got the 18. And then you will get your final answer. Let's look at this next one, number 6. I'm going to put a star by this one. This is one that people tend to miss a lot, and it's because they treat it exactly like number 5. But notice number 6 does not have parentheses, which means my summation is just this part. And at the very end, I'm going to subtract 1. Because there's not parentheses around the 3n minus 1. So I'm going to use the same formula I used last time. I like to write down my formula that I'm using. So S sub 200 is 200 divided by 2. The first term would be 3 times 1, which is 3. The nth term would be the 200th term, so 3 times 200 is 600. So 200 divided by 2 is 100 times 603. I can put that in my calculator if I need to and get my final answer. Let's move on to number 7. Number 7, I see that it's an exponential equation, so I'm going to use a geometric sum. So S sub n equals, this is where I use g sub 1 times 1 minus r to the n, all divided by 1 minus r. So this is going to be S sub 20 equals, the first term is 0.5, 1 minus the constant ratio is 0.2. I always like to protect that constant ratio with parentheses, and that would be to the 20th power. Notice these always should match. all divided by 1 minus 0.2. And I'm going to use my calculator here. Get my calculator out. All right. So let's see what I've got here. I'm going to have 0.5 times 1 minus, in parentheses, 0.2 to the 20th. That is my numerator. I hit enter, and then I divide by, I know that this is 0.8, but if you don't recognize that, you need to use parentheses divided by 1 minus 0.2. If you forget the parentheses, it will divide the answer by 1 and just subtract 0.2, which means it would give you 0.3. That's not the correct answer. You need to divide by the sum, 0.8. So you either need to put it in parentheses or do that subtraction in your head. You hit enter, and you will get your final answer. But I want you to practice putting this in your calculator, so I'm going to let you do that. Okay? All right, let's go on to the next problem. Number 8, looks like we have another geometric summation, so I'm going to use my same formula. S sub n equals the first term times 1 minus r to the n, all divided by 1 minus r. So I'm going to go ahead and use that formula. My first term, well, first of all, S sub 30 equals the first term, which is 6, 1 minus 3 halves. Now, I know that 3 halves is 1.5. If you don't, then you can leave it as 3 halves, and that would be to the 30th power, all divided by 1 minus 3 halves. Anytime I have a fraction or a negative, I really need to protect it with parentheses. Okay, this is one where you're going to have to be really careful how you type this in your calculator. So let's go ahead and do that. 6, and then in parentheses, 1 minus, protect that 3 halves with parentheses to the 30th power. So notice that I protected the 3 halves with parentheses, and you should hit enter and get that answer. Then what you're going to do is divide by, now I know that this is 1 minus 1.5, so I would be dividing by negative a half. You might not realize that, so if you didn't, that's okay. 1 minus, protect that fraction, 3 halves with parentheses, but then you have to end your other parenthesis. So the 3 halves is in its own set of parentheses. Then you hit enter, and you will get your answer. You're going to get a very large answer. It's going to be more than 2 million. So that's what you should get. Okay? All right, let's go to our next problem. Number 9. In a set of 12 nested dolls, that's where you have something sitting inside of another one. It says each doll is 8/9 the height of the next taller doll. If the height of the first doll is 18 centimeters, what is the total height of the dolls? So it's kind of like, okay, I'm going to draw stick figures here, and then each doll gets a little bit, well, actually, we start off with the biggest doll, that's what I should say, and then each doll is 8/9 the height of the previous. And etc. So that's what's happening. And they're nested, one sits inside of the other. And it's 8/9 the height, not minus 8/9, but times 8/9. So think of the first doll is 18, and every doll after that is 8/9 the height. We will pick up number 9 in our next video.